Hey everyone, Juan here. Welcome to SQL Lingua Franca, the podcast about analytics that reveals what the documentation does not cover.
SQL Lingua Franca. Bio.
Today, we have a colleague of mine, also a co author of the book. We'll talk more about it for sure. Ricardo, thank you so much for coming.
Thank you for having me. It's a pleasure to be here.
Before we even get to know you and your background in data, I'm very curious about you as a person. Would you like to introduce yourself?
Yes, of course. I am Ricardo Granados. I was born and raised in Mexico, and then I traveled with my family to Amsterdam in 2021. So almost 3 years now.
Wow,
Yeah, my wife and my baby are loving the European vibes, and now I am also enjoying a lot being a consultant over here.
that's great. Now, very specifically about your data career, and I think this is really interesting. Many of us, because there was no data career back at university, have some very interesting trajectories to landing our first data job. Would you like to tell us a little bit of the whole journey that you had to take before you got started in data?
Yeah, for sure. So for me, it was a little bit not clear that I was going to end on a data position. But I started with the idea of becoming a doctor. So I studied 2 years of med school, and then I had to drop out because I couldn't afford to finish the career. So I looked for another thing, and I ended up being industrial engineer. And there I had the first contact with some programming, C++, and these type of things. And then after in the end of the career, I had to do like an internship, social service, working in a national oil company of Mexico, Pemex. And there I had my first big break with data, working with Excel spreadsheets and Access databases. But before that, I always liked tinkered with computers and with data before, like a hobby. So yeah, I think that helped me to say yes to these tasks when they were presented to me.
So really, the internship gave you a little bit of a nudge into a certain direction.
Yes, of course, because for a very long time I thought that it was something that you just know because you learned it at school or something like that. But then I noticed that there is a very limited number of people that really knows what they're doing, and that gave me this nudge to start with data. And then yeah, it was like a snowball. Then things start growing, and I got different things related to data that made me more inclined to this role, and eventually I fully made the change in career.
Interesting. Just out of personal curiosity, you mentioned you studied some medicine and then industrial engineering. Do you think that has prepared you somehow, or you have found that knowledge useful in your career?
For sure, for sure. Having a broad knowledge, I think, gives you a wide point of view. So sometimes solutions come in the form of biological systems, or understanding just how people thinks help you to find a solution of a problem that apparently is very technical or very data related, and in the end is more about people. So I think that having this medicine background helped me a little bit with that human part of things. And then the industrial engineering prepared me on the hardware side of things. So yeah, I think it's interesting combination. Yeah.
For the record, I would have been fine if you tell me no, it didn't prepare me at all. But it's really interesting to hear that even something as different as medicine even has some components that are useful.
Yeah, for sure. And even when I was studying medicine, one thing that really I liked about that was like bioengineering and looking into this more robotic side of things. So I think that even then I was more inclined to hardware than medicine in a pure sense. But yeah, I think that everything is a little bit a push in the right direction.
That's interesting. I can also feel with my career, the things that I liked about it back then were much better reflected in a data job than in my previous career. So I can recognize some of it. But going forward, I'm very curious. Tell us about your first data job. Tell us about that internship you just mentioned.
Yeah, so in the national oil company, um, I had to do my internship. It was 6 months, and then basically they were trying to migrate to a new system for pension funds, and the bank needed to reconcile some databases with Pemex, and Pemex had different type of databases with uh, user data, and they were not in the same format. And then Pemex had a lot of information coming from different financial institutions. So basically, in the end, were a bunch of Excel files, and I needed to make sense out of it. And in the beginning, it was very simple tasks like cleaning the data, but then I started seeing the impact, because if that file had an error, that means that the money that was there was paid to another person. So it had a really tangible
Mm.
impact. So that got me into looking into guardrails, looking into how to do things right, how to have safety features, right? And I think that has come with me all along in my career. Another maybe fun fact is that during my career I did a small specialization on graphic designs for for UI, and in these Adobe Cert exams,
Okay.
I learned how to use these tools to do graphic interfaces, and that helped me to put in Excel, like use Excel like my front end. So I put some nice colors and formatted
Mm.
the text, so it was easy to navigate on the data, and just doing that, it was easier for my colleagues to find what they're looking for, and to avoid mistakes.
Yeah.
So yeah, um, that was the very first time, and then I started with data modeling. Actually, we had a very cool project. I was working with one university in Mexico, the Tecnológico Monterrey, and or the
Oh,
Monterrey
this
Institute.
is a second job, right?
Yeah, yeah.
Ah, okay.
So well, it was on parallel, because I got a scholarship for a master's while working on the national oil company, and this scholarship was tied to an investigation project, and this investigation project had to do with data from the oil sector, and seeing how it was going to evolve over the future of Mexico, because we were in the middle of a couple of big reforms back then. And then we model some data of the sector in order to do some like the first artificial intelligence models to do forecasting. They were really really simple models, but yeah, for me it was a very big project.
Okay. That sounds like a really good first project. You had everything in there from integrating systems, cleaning some like spreadsheets, communicating data. I believe you mentioned using Excel as a front end, and even some data modeling. That's, I believe, the things that every single job has in common. So I would have loved to have a first job similar to that. I think it doesn't matter where you end up in data, all of those tasks are interesting. Now, there was something that you mentioned that really caught my attention and got me wondering. That is, you mentioned that your first job was in an environment where being wrong about data had consequences. I personally have been in those environments where just not validating and triple testing your data can be disastrous. Can you maybe elaborate more? Because I know you're a consultant, you've probably seen environments where being wrong about a number matters and environments where it doesn't. Can you elaborate a little bit more in those differences?
Yeah, of course. Uh, Sometimes visibility on what you're doing is difficult, more so if you are talking about abstractions like data, right? And I think that in environments like finance or human resources, where
Healthcare.
healthcare, yeah, where a number represents a person and it has direct impact, it really hits you that what you're doing has an impact in the real world, right? And I think that consciousness helps you develop a better understanding on how to avoid mistakes, how to safeguard from errors. And yeah, sometimes people might think that you're paranoid. And for me, it happens quite frequently in the team meetings that I start asking questions about how the user can break the system, and it's like, wow, but that won't happen. But yeah, but if it can happen, right? So if we know that it can happen, we can prevent it. So sometimes these type of questions that comes to my mind help to build a more robust product in the end.
Indeed. For me personally, I only got better at testing when I work in an environment where I was told, if this number is not 11, we're going bankrupt. That's very different than working in a data environment where the number should be this more or less 10%.
Yeah, exactly. Where you have like this bandwidth of error. Yeah, yeah. I have been in those too. Like, it's close enough.
Yes,
And
looks
someplace.
good to me.
Yeah, exactly.
Yeah.
And yeah,
Oh,
and sometimes there are these type of projects where you come in and start asking questions, and then they look back in the data and they found these crazy things, and it was like, what? And we have been using that data to do this. And it's yeah, that part of observability as well, like going back and suddenly ask a question and then finding out that, oh, our assumptions were not right, or this data is not completely clean, or we didn't check this, and then finding out that there are errors here and there, and then fixing them can have a huge impact as well.
correct. Yeah, I think everything in data would be better if we would make a separation of what are our assumptions about the data and what are the things that we are doing where we could potentially introduce extra errors or biases.
Yeah, for sure. And what I think and what I encounter in the work field is that sometimes um, finding this balance and having this agreement between people, what does this mean, right? Some things like, what is a customer, and then you ask
Yes,
finance and you ask marketing, and they have different definitions of what is customer, and it's something as basic and as fundamental for the business. So getting to these common definitions sometimes is harder than all the technical difficulty that the project may have. So yeah, I really do think
yes,
that data is a very technical type of job, but that has a very human aspect, and this human aspect sometimes is the hardest part of the job.
indeed. Uh, Honestly, the physical part of data modeling can be quite interesting, quite pleasant, but sometimes you find yourself in eternal meetings, indeed, exactly what you're saying, discussing what exactly is a customer. Do you count em- employees that also happen to buy a product? Are they customers or the people that receive something free? It's lots of human challenges and interactions that really make data. But before we go there, because I know you love talking about data modeling and we're probably going to end up doing that, I already teased and I don't want to forget these parts. Can you tell us about your current job?
Yes, of course. Right now, I am a consultant. I work for Xebia Data in the Netherlands, and I'm an analytics engineer. So after being a jack of all trades, now I am consolidating myself as an analytics engineer, and our main goal is to let our clients get the most out of the data.
I mean, I would argue that every data job out there is a jack of all trades, but
Yeah, yeah. Well, we come from Latin America, and usually, like
yes,
a soccer analogy is that when they are looking for a player, sometimes they're looking for a player that is the goalkeeper and a defense, and then the frontliner at the same time. And usually, finding this type of people is very difficult to do. And I do see that we have some of these people in our team. So I think that indeed the data world is full of jack of all trades, but specifically in analytics engineering that serve as a bridge between data engineering and data analytics. I think that having a broad um, spectrum of abilities is more common.
For sure. So you work as a consultant. Can you tell us more or less how your week looks like?
Well, my week is a little bit hectic, but yeah, of course. We work. I work 40 hours with the client. That means that I have to be available for them from 9 to 5. But it's also a hybrid setup. So sometimes I'm at their office, sometimes I'm at home office, and at the same time, we have a lot of cool things doing going on the consultancy. So we have to set some time off for projects on Xebia office, and there is a lot of knowledge exchange going on. So even if 40 hours a week sounds like a lot, I end up spending a little bit more just to be with the guys and gals, just exchanging knowledge and learning from them. I think I have this blessing of being surrounded of very talented people, and every day I learn a lot from them.
Indeed, I personally believe that if you want to be great at data, you need to be internally motivated because this is not a very structured job and it definitely takes more than 40 hours that you will get in a normal job. So keeping yourself up to date, learning new things is very important.
Yeah, yeah, for sure. And uh, for me, it's a little bit funny because people ask me, "What do you do in your free time?" and or how do you spend? Yeah, how do you enjoy your free time? And usually, I am reading about data or programming or playing programming games and this type of things. So I I enjoy doing in my free time what I do for work, which I think it's a blessing. But at the
Yeah.
same time, it also become a little bit difficult to draw this line on the personal life. How much free time do you have, right? Because sometimes it feels like you never stop working. So yeah, there is a very thin line in there, and yeah, I'm still trying to find a proper balance. But I guess everyone has these
Yes.
challenges in life. So
Yeah, for sure. That's very recognizable. And I think a lot of people feel that way. Going back, you mentioned you work for clients as a consultant. Can you tell me more or less what types of assignments do you do?
yeah, for sure. So my very first assignment at Xebia was about data modeling. We were helping a client build their data warehouse. They were migrating from setup in their offices on premise to the cloud using Google. After that, I went to a big finance corporation. Now we are helping them to steer their investment portfolio using ESG data. So we help them from the gathering of the data, transformation, cleaning, presenting the data, gathering insights, and then presenting them to the credit process so they can invest in more green products. I also do some trainings related to technology we use. So, for example, Power BI or Google Data Studio or DBT. There are some the tools that we like to use. So we also help the Xebia Academy give some trainings on those. And yeah, sometimes it doesn't look like job, but assisting to conferences and talking about what we
For sure.
like. We recently wrote a book with other 6 other co-authors at Exhibia. That was the first experience of an author for me, so that was very exciting. So there is a lot of things going on, and I really like it.
Nice. Let me come back to the book. But first, you already told us a little bit about your experience as a consultant, but now I want to ask you, what would be your ideal consultancy assignment? Tell me from the how it looks like to what technologies you're using, just to get to know you.
Wow, that is a very deep question. Um, I like to get things done. So usually I like things where I can start working right away. But what I really enjoy, for example, is transforming data from raw sources into actionable data sets. So basically, building a data warehouse is very good example where we take the raw input and then we transform it into different models in order for the client to get knowledge out of their data. um, I also like the technical part that comes of solving problems with the data pipelines, moving data from A to B. So yeah, on the tooling side of things, I like to work with Airflow, for example. I think it's a very versatile tool. And for data transformations, I mean, as the title of this podcast, SQL is our main tool, but a program would be like DBT. That is my tool of choice. Um, we also use other type of tooling like PySpark or Python, depending on the client needs. But yeah, I think that transformation is what I like the most on all the data value chain.
Indeed, that seems to be a recurring topic from data modeling to transformations, building pipelines, and ultimately bringing value to the end consumer.
Yeah, yeah, for sure. And yeah, if it's needed, I can also do the dashboard, but I know that there are more talented people doing dashboard than me. I can do a decent job, and my graphic design background helped me a little bit on making it look good. But at the end, yeah, I feel more comfortable in the first stages of the value chain.
Interesting. Now let's go back to the book. That was a really big release. I just wanted to get to know you when you did consultancy week, but now tell me more about the book.
Yeah, for me, it was very interesting. It's the first time I write a book that is going to be published and sold in Amazon. So that was very exciting. I never had been part of this editorial process, and for me, writing was a little bit too easy. I think from the seven co-authors, I was the one that wrote more pages on the first try, and then trimming it down was a little bit of a nightmare. But yeah, as you mentioned, sometimes I get passionate about these topics and I start rambling about, and then I get distracted. So yeah, my colleagues and the editorial helped me to get the chapter under control, reduce the number of pages, and go to directly to the point. And yeah, I am very grateful for that. Also, reading the other chapters was very interesting. I learned
Yes.
a lot from my colleagues. What is interesting about this book is that every co-author has a very distinctive way of writing, and even though we made our best to change the logic and to have a common story, you can feel the personality of each of the authors in each chapter. So I think that is also good because you see that it's not just one person with a lot of opinions of something, but very group of talented people writing about what they're like and what they're best doing. Yeah.
Yeah, it's interesting. Most people writing technical books, I would dare to say maybe all of us, we had no background in writing. So it's really just like taking the knowledge that you know and just learning the basics of writing all along. And it's the job of the publishers to really nail down and tell us like this is too much, this is too little. Edit, make sure that yeah, somebody trims and corrects. Because yeah, the technical part is there, but writing a book is a very interesting journey.
Yeah, for sure. And we also, I think, we have this problem of taking things for granted. So we tend to think that everyone knows what we know. So you start writing about some topic without the basis, and then you notice halfway through that maybe not everyone knows about the basic statements you're doing. So you need to go back and then give a little bit more of context and try to explain a little bit better. And I think that is also a good exercise for me at least
Yeah.
to see if I really got the basics right and if I really understand the topic at hand.
Yes, I will never forget how the editor told me, what exactly is a PR? And I realized, like, oh, okay, let me write pull request out loud in every single part. Going back, I don't think you have mentioned the title of the book, have you?
I haven't. No, the
Oh.
book is called Fundamentals of Analytics Engineering, Building Analytical Pipelines from End to End. And yeah, it's published by Pact, and it's available on Amazon, full disclosure.
Okay.
So you can look it there.
Tell me, who's the ideal reader of this book?
So I think that we try to cover different audiences with the same point of view. So if you are a data professional that wants to steer your career, maybe you are a data analyst that are intrigued by the technical parts and you want to become a little bit more technical and go into the data engineering section, or the other way around, maybe you are a very technical person and you want to get more in contact with the business and extracting more value for the company you work for. I think analytics engineering is a role you can look into, and this book can help you understand what it entails and what are the basic skills that you need to develop in order to become a great analytics engineer. Um, One of our reviewers said that this book is not going to make you an expert analytics engineer, but it's giving you the fundamentals. So I agree with that. The other public that I think would benefit the most of the book is people that need to hire an analytics engineer and don't know
Mm.
what it looks what the role looks like. So what do I ask for in the in the role description and these
Well,
type of things?
yeah, you can literally use the outline as like a checklist of skills that you expect in this person.
Yeah, for sure, and maybe grab one or two questions from the interview as well. Um, the other thing that I think is valuable of the book is people that is not from the data environment but want to know a little bit more on how to extract knowledge of their data. I think that now more than ever, data is like a transversal thing. So no matter what you do, you have to deal with data, and these skills I think have value for anyone working on any field. So if you need to work with data, maybe having a look at these skills and a little bit of these tips and tricks that we share in the book can help you get the most out of your data without having to hire a data engineer or becoming yourself a data professional.
There are there are two pieces that are missing right now, just as a background for everybody listening. The first one is, what exactly is our definition about analytics engineering? And I know it's interesting because you were pretty much involved with that part. And the second is, what exactly are those skills? But maybe let's start by the definition.
That is actually one of the biggest points we had to tackle during the writing of the book, because we started our research and we started looking for definitions already there and what the industry said about analytics engineering. And we saw that everyone has its own definition of what analytics engineering is. And they have subtle differences. And although we agreed with most of them, we thought that we needed to write our own definition that was like tool agnostic and a broader term that defines what an analytics engineer is. So I will read the definition. So for us, analytics engineers are the bridge between business and data engineering. And by adhering to software engineering best practices, they build and maintain robust transformation pipelines to produce high quality datasets. With this process, they improve the accessibility and reliability of data products. The analytics engineer is a center role in empowering end user to make truly data informed decisions. So basically, we find the analytics engineer sitting between the two major roles in data, that is data engineering and data analysts, and it empowers the data consumers of the pipeline. So the data scientists get benefit as well from this role that help to put best practices in place.
Yes. And now that's a perfect bridge. This definition is pretty functional. But let's go back to what you mentioned and tell me what are the skills that an analytics engineer needs?
Well, the analytics engineer has to think differently because uh, I have been working with data engineers, and they are very good of thinking on how to move data in the most efficient way from point A to point B. And then I also have been working with data analysts that they have all these questions in their head of, and they know exactly where the data is, right? So if you ask about profit, they know which tables to look for and where the data lives and what does this means. And usually they are the ones that know the horror stories in the company, like, oh yeah, that table we created because of this and because of that.
Yeah.
But the analytics engineer, I think, has to have the mindset of how to create repeatable and reproducible patterns to move data from one to B in order to not reinvent the wheel every time. How to properly test the data to avoid errors, how to serve the data in a better way. So uh, we used an analogy of a supermarket where if you see the chain for moving the goods to the supermarket, the data engineers would be these trucks that get the produce from the producer to the warehouse, right? They move the product and they say to you, these boxes will arrive at X amount of time, and I make sure that they won't go bad in the way. And then you have the data analysts that sit beside the cashiers, and they know how much product has been sold that day and how much profit they have. But then there is one role that is missing in the
Between.
middle. Who is the one that ordered the food inside the store? Who decides where is the best way to put it so the client can find it easily? Who orders the expiry date products in the front in order to not letting go bad, right? So I think that the analytics engineer is this one that makes things more efficient in the middle. So it facilitates this transition between moving data and serving data.
Yes. And I'm already going to play devil's advocate for the people that are listening to. Many people will say, like, yeah, but that's something that a data engineer does in our organization. And I think we would both agree here that that gap between a data analyst or really any type of data consumer, could also be data scientists, like you mentioned, and data engineers does exist. It's just historically either a very technical analyst or maybe a data engineer that is more willing to collaborate, work with the business, and meet them. We're still doing that. I really think that labor has always existed. We're just now coining a term and appointing a professional to do this particular part that before would fall somewhere else.
Yeah, for sure. And I think that the story and the technical advancement has been reshaping this new role because when you had on-premises systems and the database were in your own building and you own them, the data engineer made sure that the datasets were clean, that the datasets were where they supposed to be, and the data analysts were directly to that database and look for the data in there. Now that we move to the cloud, this distance between who moves the data and who serves the data increased, and this bridge is needed now because the data engineering team now has to deal with a lot of platform issues. So I think that the data engineering role is evolving into more like infrastructure as code and this type of solutions that keep things working to move data from A to B. And the analytics side of things also had this evolution where suddenly, because the data engineering team was too full with work, they had to start transforming the data, cleaning their data. You see all of these BI tools, including powerful tools inside them to transform data. So now you find that you have different data models in the BI tool and in the data warehouse and in
Yes.
the raw source, and then you start with the chaos.
Nightmare material.
Yeah, so I believe that this analytics engineering role that sits in the middle was born out of necessity. So it was to put some order in this middle part that now grew in size and grew apart. And if you don't have an analytics engineer, then the data analyst needs to stop doing what he does best to extract knowledge and go into the data warehouse and put some order there,
Yeah.
or the other way around. Maybe your data engineer needs to stop working on the platform and move the products. So
Agree. I started learning SQL because nobody was willing to do a job for me.
yeah, exactly. So I think that it's a natural evolution of the roles, and one of the consequences of changing from transformation, and loading data to extracting, loading, and transforming data. That is one of the chapters of the book, actually, and because we think that it has a big impact on how the data teams are conformed now and the activities that the data professionals need to do.
You mentioned a hot take earlier, which I also think is definitely interesting to mention, and that is you think data engineering is evolving towards platform engineering. Can you elaborate a bit more about that?
Yeah, so I see that the technical challenges are growing on the platform level. So if you are working with the cloud, or you have different vendors, or you have different tools, then the data engineering team have their hands full, making sure all these systems work together, work properly, and that you have enough reliance on those infrastructure to move your data around. But that also means that they have less time to check the quality of the data and go inside the actual data to see what is this about and stuff. More so when you are dealing with files, and these files are dumped into a data lake, uh, then it's more difficult to control who can see what and what type of information that is. And even though the data lakes enables data scientists to go into the raw data and get their hands dirty and play with non-transformed data, it also means that you add another governance layer on your data platform. And yeah, it's really easy to go from a data lake to a data swamp and don't know what is there. So I think that the data engineer is evolving into having and maintaining these platforms and infrastructure in a reliable way to make sure that the data goes from A to B without any issue in time.
I'm willing to say that if you ever found yourself asking the business how a business process work, like, hey, can you explain to me how promotions are calculated, or how the returns are done here, or what happens when somebody picks up the product? If you ever found yourself asking those types of things to the business and translating them into SQL, regardless of your job title, I think you might be an analytics engineer.
Oh, that is a really good take on that.
Yeah.
Yeah, and that is one of the things I really like about data modeling, because one of the first stages of it is exactly understanding the business, understanding what you do to bring value, and then translating that into actionable code to transform your data. And yeah, I didn't thought of it like a direct one to one, but yeah, now that you mention it, I also recognize that.
Yeah, at least to me, it's a little bit about getting your hands dirty and interacting with people.
Yeah, for sure. And uh, I've seen other like other media or other type of blogs or podcasts talking about data that recognize this analytics person, this analytics professional that is tech savvy, or that it's more technical than the um, average analyst, data analyst, and yeah, I think that if you find yourself creating dashboards, but you have to transform your data, clean your data, and transform this business insight into actionable code, then you can also think yourself as an analytics engineer.
So yes, you're probably not an analyst anymore.
Yeah, exactly. Yeah, you're getting out of your box.
Interesting. Ricardo, I know you had a lot of working in the data modeling chapter of the book, and I know that's also one of your passions. And so I have an interesting question, and I'm really curious about your take there. That is, when you're trying to hire somebody that is an expert in data modeling, what are the things that you would look for?
Well, that is a very interesting question because, yeah, usually we are involved into the hiring interviews. So the first thing I try to look for is to see if they know what a data model is. But beyond that, why is it important and why we're doing it? Because sometimes it's very easy to fall into the trap like I am pro dimensional modeling or I'm pro X modeling technique, and then blind yourself to anything else. And if it's not the flavor you like, then it's not a good data model. And I think that now the data platforms and the data requirements for each business are so widely different that you are going to end having different data models in different stages of your data platform. And you need to know a little bit of each one. Maybe not be an expert on all of them, but and know them and see what are their main points and main strengths.
You're talking about like things like Kimball, Data Vault, and so on, right?
Yeah, exactly.
Yeah.
Yeah. So the corporate information factory from Inmon, or the dimensional modeling, the enterprise data warehouse for Ralph Kimball, or the business intelligence platform from or Data Vault 2.0 from Daniel Instead, that try to tackle different things on the data warehousing, specifically on the data warehousing. But then if you go to the BI realm, you see other type of models like one big table, or the normalized models that help the BI tool to serve faster the data. And usually knowing what to use, it's a big question. And sometimes you need to use different in combination. So um, I think that if you're going to model data, you need to be open-minded and try to exploit the best characteristics of what is out there to get the most out of your data.
Which is interesting because we have all of these methodologies and ways of doing data modeling. Well, at least maybe the physical side. And what I noticed quite a lot is we're in an age where a lot of people are handpicking some of the things that you like from this one, some of the things that you like from this one. Sometimes for better, sometimes for worse. But that seems to be a little bit what you were mentioning, right?
Yeah, but well, there is a small difference between cherry picking what you like of the methodology and using different modeling techniques, right? If you
Yep.
decide to use Kimball, then I expect to see your dimension and your facts clearly in your data model. If you say that you are using Kimball and I see normalized tables in your data model, then it's not Kimball. So I think that for if you really want to benefit from the methodologies that you're using, you need to follow their standards, and you need to do things right. What I think is that you need to be open to the idea of, okay, for this system I need to model this in this way, and for this other one it's better if I do this other thing, and maybe this third system needs a very hard audit, and it's very different from others, so I better use this other technique. So I think that that is what I mean of being open-minded. Because if you start cherry picking small parts of one methodology, then you end up with a Frankenstein, and then nobody understands what you're doing.
By system, you mean technology or more like the environment, the company, the constraints?
That's a good question. So when I mean system, is like the data system. So it can be the data warehouse or
Okay.
the cloud environment. But yeah, sometimes that barrier it's a little, or that line is a little bit hard to draw, because the business can also have different views on things, and maybe you have data outside of your data system. That is the case, for example, with a lot of spreadsheets, Excel spreadsheets that are going around in emails here and there in many companies that we know. Uh, that is data that is not in your data system, and you need to account for. That is also a challenge.
Interesting. I think what we have been talking so far is really towards the physical and sometimes a little bit of the logical side of data modeling, but we haven't talked too much about the conceptual.
No, that's true. So I think that the conceptual side of data modeling is tied more with the business side of things. So usually, what starts these conversations is, um, if you are going to create a system from scratch, or if you're going to migrate a system from one system to the other. Then usually you start asking the business what you want to achieve, where is your value, what are the things that you want to measure, and then you start looking into things that become key point areas, and then key process areas and key point of interest. Um, so then you start defining metrics, and then you can go into the logical how the data connects. So I think the conceptual part of the thing of data modeling is more on the how the business works, understanding the business and translating that into how the data will represent it better.
In an ideal universe, I would think the business fully handles the conceptual modeling part. Logical is more of a negotiation between the data team and the business. And then the physical implementation is 100% up to the data team. Now, in practice, quite often we as technical implementators, we end up doing everything from the conceptual and even understanding how the business works.
Yeah, I see that a lot. Sadly, I see also that many data professionals start to think that data modeling now is a waste of time, and they don't spend enough time on the conceptual and logical data models, because they feel like the physical model of the data model has everything in it. So why spend time and effort in the other things? Let's be agile, go directly to the physical. And then I like to think this as an analogy. If you
Sure.
are if you're given 1,000 Lego blocks, and they ask you to build a car, the most probable thing is that you end up with a car. But if I give you a model with instructions on how to build an F1 car with those 1,000 Lego bricks, your car is going to look more professional than the one that you would build without these instructions. So I think that that is data modeling. You first decide how it's going to look, what is it going to be used for, and then you start building, and not doing the conceptual and logical steps. It's just go running to start building, and you end up with something that might resemble something usable, but maybe not the best for the long term.
Indeed. How I heard that recently, nobody builds a building without a blueprint.
Yes, well, yeah. I come from Latin America, and I know,
Okay, fair enough. Me too.
I know people that do. But yeah, that is an excellent example. If you look for a house that is not being built with a blueprint, then you can see how
Yeah.
then the son-in-law then came in, and then a new room was added without thinking, or a third floor without asking if the structure can handle it, and then a lot of accidents happen, or yeah, it looks like it don't belong there.
Yeah.
So I think it's the same analogy.
At the same time, I don't necessarily blame us data professionals for having such a big emphasis on the physical part of data modeling. Because as somebody that recently started doing the conceptual part, I've noticed it's really hard. And I don't think that many people are built for that. Like, you really need to be able to go talk to very important people in a company and get them to agree to things that they consider very trivial, like, no, tell me when exactly somebody becomes a customer, or what should be the official word for this in French, or the official word for this in English, Spanish, or whatever places where your company also happens to sell. And that requires a lot of buy-in, that requires a lot of work. So I see a lot of people might be tempted to, no, I get hired to the SQL part, and it should have been your business to get this done and give me these documents.
Yeah, yeah, for sure. I understand that part. Again, as I mentioned in the beginning of this episode, I feel like the human part of the data projects are the hardest one. And of course, dealing with the business, talking with these people that have not enough time to talk about these topics, it's difficult. Another thing that changed the perspective, and I think it's the major point on why data professionals now see data models as a waste of time, is that cloud infrastructure now makes very easy to overcome uh, the effects of having a bad data model. So basically, if you have a bad data model, then you struggle a little bit extracting knowledge from your data, doing computation on them, doing calculations of them. And now that you have infinite compute in the cloud, it makes the problem how much I want to spend on compute rather than if I model my data correctly. So if you can move faster to your target, get the product out there, even if the data model is not as good, and then you can get away with it just with a little bit more compute on the cloud, it works. So
Interesting. Like building a parallel with what you mentioned at the beginning. Just like in some companies, there is no consequence if you get a number wrong. I think for a lot of people working on data, there is no consequence if you do the modeling wrong or a bit inefficiently.
yeah, and what happens with that is that if you do something that is not as efficient as it can be, as long as it works, it is not a problem. So as long as it doesn't break, no one is going to fix it because it's still working, right? So it doesn't matter if it's the ugliest SQL query you have ever seen, and if it has more than 1,000 lines. If it works and it gives you a result that finance is happy with at the end of the day, then that is good enough, right? But I have been on the other side of things when I have to clean that mess, and then you start refactoring things, you start
The
making
joy.
the right data model, and then of course you start seeing that the compute start going down, you can do it things faster, that you can process more data, and then you start saving money. And then the business says like, oh, I like this, but they don't know it because it's not a problem until it's broken.
Yes, indeed. That's quite often the job of a consultant, fixing all of those things that people didn't expect were gonna break. But Ricardo, I know you know quite a lot about the topic. I also love talking about data modeling. We're probably not gonna scratch the surface today. But if you could leave the people listening with some very actionable tips, like how can they become better at data modeling, what would you say?
Well, I think that as everything in life, things get better with practice and with time. So, if you really want to learn about data modeling, I suggest to start doing it. Pet projects. There are some data sets that are public. Some of them are very big, so it becomes quite a challenge. There are open source tools that you can use to do it without almost zero cost. So
Name one or two.
yeah, for example, you can use DocDB, for example. If you want to use BigQuery also have like a very generous free tier that you can start using if you want to learn how to use cloud computing. DBT is also the CLI version. It's also free to use, and there is actually a package called DBT DocDB. So with that in a
Yep.
box, you have everything ready to start your mini data platform, and you can start doing things. So that's one thing. Keep improving yourself. Keep reading. Keep learning about these topics because they are evolving every day. The other thing that I would recommend is be open-minded. learn about everything a little bit, see what are the main points, what are the not so good points of one technique or the other, and try to understand when is better to use what. And I think that with and I think that we take you a long way.
So those are quite a lot of tips. Indeed, just keep on learning, be open minded, and also don't be afraid of starting your own data platform in your own computer with your own open source data, whatever it is. I think it's really true. All of us working in data, we do need our own project to practice things here and there. I personally have also a couple of things that every time that a client asks me for something, I try to replicate it there. So those are very important tips.
Yeah, for sure. And also, if you can broaden your network, like assisting to meetups or going to conferences and learn about new things, I think also that helps a lot to get in touch with new things and learning new stuff.
Yes. Yeah, which is honestly the reason I started this podcast. Plenty of very amazing people you can learn from. Good. Any final words, Ricardo?
Well, I enjoyed very much being here with you today. And yeah, as you mentioned, I really enjoyed talking about this topic. So you can look for me at LinkedIn. I will happily answer the messages and interact with people there. Also, if you have questions about the book, I can ask our co-authors or look to give you information about the book. And yeah, thank you very much for having me. And let's see if we can